Okay, alright, here we go.
X squared.
Which one is that?
Hey, can you see?
28, right?
I just want to see.
Hey. Alright, here's what I want to talk about today. This is the question that we brought up that I've been waiting until this section to try to introduce it. So, this is the problem that I want to talk about today. It's one problem, it's just a parabola. So, x squared plus 6x plus, let's just go with 5. We'll just kind of make it easy. I don't want to pick anything too difficult. So, here's the idea. What this problem is it's a parabola. We can go draw it. We know the tails are going up by end behavior. You know, the tail's going up on both sides. It's an even power. It's got a positive 1 out front. So we know the tails go up. When you're going to draw, it's got one turning point that we'll eventually figure out. It's got an x-intercept. Now, here's the idea. The x-intercepts are super easy. You factor it apart if possible. If you can't factor it, that's when you have to take the back number, put it over the front number, do all the different factors of those, and then divide them off by polynomial division.
That's kind of a drag.
That is a drag. We're not doing that today. Now, here's the idea. Okay, these are x-intercepts. It's very easy. We know that'll make the 6 in the middle. So that means it has x-intercepts of -5 and -1, right? We understand that. It's got a y-intercept. It's got a y-intercept of +5. These are x-intercepts. Okay, do we understand kind of the generic look of what this thing is doing?
Yes.
Okay, 1, 2, 3, 4, 5, -1, -5, 1, 2, 3, 4. Okay, so this is kind of what it's looking like. And the question was, 2 days ago, and it was a great question, how do we know where it has that turnaround point? That's what I want to introduce today. It's one simple problem that I want to show you. You've done it before, 2 different ways, in fact, in pre-calc. And it's one of those things I want to show you today, and then we're done. It's pretty straightforward.
Promise?
Now, yes, this is our only problem we're doing. Square. Okay, so here's the first way we've done it. Okay, we've completed the square where you move the 5 across the equal sign on the original problem. Right, you move that 5 over, and then you complete the square. Bless you. So completing the square means you take half the middle and you square that number. So half the middle on this polynomial, half the middle is 3, we square it's 9. We're going to add that to both sides. Okay, you're going to add that number magically to both sides. If you remember doing that in pre-calc, we did. It was called completing the square. Now on this one side over here, this ends up being y plus 4. On the other side, I can factor this apart. Now, it's going to end up being the 2 parentheses that are exactly the same. They're going to be x plus 3, x plus 3. So there's actually 2 of them, okay?
Oh, I get it.
When we factored apart, right? That's the way of completing the square. We made that number in such a way that it would work out perfectly that way. Now, the turnaround point, where the lowest point it's dipping, is the coordinate that goes with the x and goes with the y. So what's the opposite number that goes with x?
-3.
3?
-4.
-4. There's your turnaround point. Now, here's the idea.
Holy cow.
Now, we've done that before, right? It's literally the vertex. -3 over, -4 down. That's the point where it turned around. Okay? But here's the problem. We did problems the other day on the homework where, you're having multiple turning points and, it had, maybe it was kind of going different directions. We had horizontal and vertical asymptotes. We don't have the luxury of doing this, completing the square every single time. That method, it's really clever. That's a great way of doing it. The problem is it doesn't work every time. That's where we have a new method. The new method is something we did. It was done in the first chapter of pre-calc. It was section 1.3 or 1.4. Doing the other method of doing this problem.
I remember that.
Okay? It is called the differential quotient.
Yeah.
Okay? So I'm going to put this on the board so you can see it. This is my absolute last bit of note here. So, it's called the differential quotient. This method is a method that works every single time to figure out the highest and lowest points on any curve, but it's a process. It is kind of a weird way of doing it. So, here's what it does. And this, I'm going to try to explain this the best I can. This is an intro day. So, it's the limit as h approaches 0, and I'll explain what that means here in a second. And what you do is you take the original function that I was given, and you plug in an x plus h into it. like substituting x plus
I
h.
love
It's so like you get all those
And
parameters.
then you subtract f of x off of it, the original function, and you always divide by h. And we did this in pre-calc. It was like the first chapter, right? This process of doing it actually gives you these points right here.
Is there a shortcut for this or what?
Yes, eventually. That's like chapter 3 stuff.
We can just skip
Okay.
that.
We could just take a shortcut to the shortcut.
No, so we do need to learn the actual math here. So here's the idea. I want to show you this idea today, like what it is. Now, what this process will do, it will eventually give me where the lowest point is. Now, it's not going to like, if I do this process, it's not going to immediately go, oh, here, the answer is -3, -4. It's going to give me the idea of how to go find it, if that makes any sense. It'll give me a formula that all I have to do is plug in one number, and it'll spit out my answer, if that makes sense. So, here's the idea. I'm going to do it for this problem. Seriously.
Do you want me to get it for you?
No, I know.
So Sam, finish the answer. 2x squared over x squared plus 2.
Yeah, I got it.
That's it? I think so.
Yep.
Alright.
What?
I looked at the graph.
That's that? What?
No, he's homework problem.
Oh,
I looked at the graph and I'm like, oh. Was that your ex calling?
Is that a serious call?
Yes.
Are you in trouble for something?
No, I have to do something right now.
Is you in trouble?
No.
Will
Is
he
it
be in
gonna
trouble if you don't
interrupt
do
that
it?
5 minutes?
Ward is a good boy.
It's been waiting.
Will he be in trouble if you don't do it?
Play you.
Yes.
Can you tell us what it is?
No.
Is it confidential?
How much trouble?
It's more, is it more?
Enough where I have to do it right now.
So you're saying that it's more important than our education?
Yes.
Oh.
Is it for homecoming?
Might as well just go.
And it's not more important than our
Do you get the dance
education.
applause?
This 21 questions or what?
It's definitely who just won the player.
No, it's not.
Oh, we have to decorate today, don't we?
Yeah.
Okay.
The dance floor.
Are does?
David, did you get a haircut?
Why did you do that?
I hate it, Jason.
Okay, alright. So, okay,
It's only
hey, here's the idea. I'm going to try to go through this as fast as I can. So, limit as h approaches 0. I'm going to plug the original function, but I'm going to plug x plus h's into everything. So there's a 6, x plus h plus 5, and then I'm going to subtract the original function, which is x squared plus 6x plus 5. Okay, so, and this is all over h. Okay, now when you plug in the x plus h and you square it, you have to FOIL that all out. What this does, what this whole thing is, what this limit is doing, is it's figuring out as I squeeze closer and closer together, where I make this distance, which they call h, it's a mythical number, it's just like this difference in, not height, but it's a difference in number. When they squeeze this difference down to 0, where there's literally no gap, it will point at where the lowest points are. It could do it for multiple times. That's why it's going to spit out a formula that will give you the option of having multiple different answers. So it'll point at each one of them separately, which is kind of cool. So now, doing this problem out, this is going to be, I'm going to FOIL this out. This is not distributing power 2, this is doing 2 parentheses, FOILing out. It's x squared plus 2xh's plus h squared. That's like FOILing for second class. Distributing the next part is 6x plus 6h plus 5. I'm going to distribute the negative sign through that back parenthesis. So there you go. And then I'm going to divide by h, and this is all as the limit as h approaches 0, because I want that h to be as low as possible. I want it to approach 0. That's a limit as you get closer and closer to 0. Now, on the top, if you did this right, things without h's should cancel out. That's how you know you're doing this right. Okay? Only things with h's are left. So I'm left with h squared plus 2xh plus 6h. And this is all over h as limit as h approaches 0. Now, next thing, divide everything by h. So if I do this correctly, here's what we have. Dividing everything by h, I'm left with h plus 2x plus 6. Right? That's dividing everything by h. Canceling out one of the h's. And the last step is now plugging a bunch of zeros into all the h's. As h approaches 0, what would your formula be? Well, my formula would be this. Does that make sense? When I plugged in h of 0. What that is a formula that will give me every single spot where I will have a hill or valley. It is a formula that will highlight that spot. How I know of that? What this actually is doing is finding all the points where it suddenly changes directions. It goes from like going slow to going fast, that type of thing. Well, when I change directions, what happens at this exact moment if this represents like speed? What would this moment be in terms of speed?
0.
0. Okay? You'd stopped. Then you start speeding up again. Does that make sense? So, it doesn't matter what you thought of it as. Maybe this is your profits or losses. So you're going down to a point where you have 0 of something, and then you start to gain. It was like a turning point, right? So, to figure out where this point is using your formula, because my formula right now is this, all you have to do is set it equal to 0. When will I have my speed, my rate of change, turning into a 0? So, that, if I subtract this over, and you always put it equal to 0. That's how I always know. Whatever this formula is, you always set it equal to 0. So I'm going to move that over. That's -3. Oh, sorry. -6. Divided by 2, and you get -3. Now, this number. Now, even if you have more than one, it will spit out all of them. Because you might need to be able to factor this apart or figure out all the different roots that will give me this 0. In this case, there was only one answer. It was at -3. That was my x. And that was the coordinate right here. And then to find the y number, now that you know what the x number is, all you have to do is plug the -3 in there, and it will spit out your other number, which is -4.
That's nice.
That's so much work.
It's a lot of work. Obviously, there is shortcuts. You guys already identified this. We are not going to learn the shortcuts right away. The reason why, you do need to learn the process of doing this. This is actually the real math. The shortcut is literally like a gross, like, version of like shortening all this up by, it's not real mathematics, it's just a way that somebody has noticed a shortcut.
Cheating.
It's kind of like a cheating method of doing
So you want
it.
to
So the idea is eventually we will learn it, but you have to display to me at some point you can do this. That's it for today, we're done. You will have the rest of the time where you can work on whatever else you need to.
Done, finished, complete, however you want to say it.